Welcome back. In this chapter, we'll tackle 3-point light setup. So why 3-point light setup? 3-point light setups is probably what you'll find the most often in nature. It represents 3 different lights. Obviously, that's where the name comes from, and is going to usually look pretty good in most scenarios. And so very similar to to color harmonies and things like that. We talk about this because it works and it looks good, and of course, like I said, it is what you will find in nature kind of by default. So then the first question is probably, what are those 3 lights? What do they represent? Especially in nature here where there's no artificial light. And by the way, everything that we cover here can also apply to artificial lights. It is something that is pretty universal, and as long as you understand how we're going to do this, you should be able to add as many lights as you want in your scene. The same theory would still apply. So in this chapter, we'll take a look at 3 different lights. The first one being the sunlight. The second light source will be what's called a bounce light. And finally, in third, we'll have the skylight. Now, the order that I have here, they are in order of intensity. So the sunlight will be the brightest of them all, of course. The bounce light from the sunlight will be bright, but not nearly as bright as the direct sunlight. And the skylight will be the weakest of them all by a lot. But you can probably notice at least one difference between the sunlight and the skylight. The sunlight comes from a single point in the sky, right? The sun. There's no other sun. It's not like we have 5 suns shooting sunlight in a bunch of directions. We only have one sun shooting light in one direction at any given time. The sky, well, it's very different. It covers a huge area. It covers the entire sky. So there's going to be light coming from every direction. And that is going to be the main difference between the skylight and the sunlight. And even though the skylight is really, really weak, you can compare it to like a really subtle mist, when it's not quite raining, but just kind of just drizzle. And the sunlight in that same comparison would be a very strong stream of water, like something coming out of a fire truck. Now, when talking about the bounce light, it will be kind of in the middle, kind of the 2 at the same time. We'll see that very shortly. So the way that we're going to tackle lighting up this scene here, because as we can see, it really needs shading. It's hard to understand what's happening here. We don't know where the light is coming from. We have a lot of work to do before this looks like a lit scene. And so what I generally like to do is tackle those lights here in order of intensity. So I'm going to start with the sun. The sun will be the first one here because it's the most intense by far. And in this context, in the context of this particular example, we'll take a situation where it's very simple. The sunlight will be, well, a kind of like this light color, this light yellow color, and will be coming straight down. So it's as if it's noon and the sun is shining straight down on us. Now, what does that do? It means that those walls here on the side, they won't be casting any shadow. The light particles coming down from the sun will be completely parallel to the walls, and so there won't be any kind of angle like this where any shadow can be cast. However, this little roof right here, below the roof, well, this thing is going to cast a shadow, and the cube, just like the walls, won't be casting any shadow either. But this sphere right here, there's like the dark side of the sphere, right? So below this area here, the sun won't be able to reach if it's coming straight down. So what we can do at the very beginning is consider that there's no light at all. So everything is black. There's no light, nothing. It's not 100% black, just so that we can see a little bit better, but you get the idea. It's as if it was completely black. And we're on the moon. But then the sun happens. And since the sun is coming straight down, well, where are the areas that are going to receive or going to be able to be hit by the light of the sun? Those areas are going to be all the areas that are pointing up, right? So on the top of this little box here, we're going to have sunlight. On the top half of this sphere, we're going to get sunlight, and on the top of this little roof here as well, and of course on the ground. And so we would get something like this, right? So all the light particles from the sun coming straight down. So they're not touching the wall. They're touching, of course, the top of the wall here, but we can't see that from our point of view. And they all go straight down, hit that box right here, and straight down to the ground, the top of this sphere, and the top of the little roof. But that's it. And then there's one thing that's missing. It's where it can't actually reach, and those will be the shadows here. So we're gonna have those shadows, some dark shadows, because the sun from the light is being completely blocked by those two objects. And since, again, the light of the sun is coming straight down, that shadow will be as if we just continued the roof all the way to the floor right here. So extremely simple. Now, this doesn't look too good, does it? It looks like we're on the moon. It just doesn't feel like those walls here should be this dark. And it doesn't feel like in the broad daylight here, the shadows should be completely black, especially after what we've seen so far. Which brings us to bounce light. Light from the sun here is going to be straight down, right? So we'll have kind of like a tiny reminder here. Bounce light is whatever happens after those light particles from the sun come in contact with any surface. Now, some will be absorbed by the surface depending on its color, depending on its material, but there will be particles that will bounce off of it, just like those bouncing balls, like we've mentioned before. Now, the bounce light will be what happens when those same light particles bounce off of an object and then back onto a different object. That is what we call the bounce light. And although it's not as strong as the sunlight, as the direct rays from the sun, it's still pretty significant. So let's say we have these 5 particles of light coming from the top here all the way onto that box. Now, for the floor to look like this gray color here, it means that it wasn't white at the beginning. So it was probably a gray floor, right? Without any color or anything like that, to keep it simple. But this also means that because of the color and because we can only see gray as a result, some of those light particles were absorbed before they were able to bounce back into our eyes so that we could see them. We can identify those, maybe these two right here, as the light particles that were absorbed by the surface of the cube. Now, I've only drawn 5 light particles. Obviously, there's almost an infinity everywhere bouncing around in the scene. But if we consider the ones that we have here, and we consider that those 3 ones right there, those are going to bounce. They weren't absorbed, lucky them, and they can bounce back somewhere. So maybe this one will go right here onto that wall. Maybe that bounce here, well, this one will go back into the sky, so we will never see it again. And maybe this one in the center will bounce onto this wall here on the right. So what does this indicate to us? Well, the sunlight came with a lot of particles. It hit that box pretty hard. And now we have some residual kind of light bouncing around, obviously not as strong, right? So here we only have one particle on the side compared to the 5 that landed on this box. So again, just to illustrate that bounce light is not as intense, it's a lot weaker. But if you multiply this by a bajillion of times, all these tiny particles here that bounce back up onto this wall, it's like all these little dots here everywhere, infinitely small, but they do add up and as a result, light up the wall a little bit. And in turn, they make the surface of the cube and the surface on the ground and whatever is being lit directly by the sun, they turn those surfaces into secondary light sources, into bounce light sources. But what color should that light source be now? What color should the bounce light be? Is it going to be the same color as the sun? It depends, right? So in this particular case here, we don't have any color in our scene. So the sunlight will just lose intensity as it bounces around, but it won't change color. Now, if this box was red, on the other hand, what does that mean? It means that every color in the spectrum is absorbed except red, which is why we can't see it. It's able to bounce back. The bounce light in that case would be red. If the box was purple, the bounce light would be purple, etc., etc. So maybe for our example, we're going to have a blue box. And so this means that this ray right here will be of the same color as well. But that's only the bounce light coming from this box. But now when the sunlight, on the other hand, hits the ground here, well, the ground doesn't have that color, it's not blue. So the bounce light in this case will be of a different color. So now that we understand how bounce light works, and we can actually add the bounce light in our scene to make this look a little bit better. Knowing that the intensity of the bounce light will be less than the intensity of the sun, the walls here or every other area receiving bounce light won't be as bright as the floor right here, right? The floor will be the brightest, the top of the sphere here will be the brightest, everything that's facing the sun directly will be the brightest. And so what we can do, we can just approximate it, right? So the bounce light, the intensity of the bounce light will completely depend on the intensity of the sun or the intensity of the main light source. You know, if in this case it's the sun, but it could be something else. And so if the intensity was higher, maybe the ground would be a little bit brighter. But in this case, we're just going to go off of that and maybe just reduce the intensity to something like a third of the intensity found on the ground. So where's that bounce light going to go? We're going to get some light here, a lot of the light of the sun hitting the ground and back onto those walls. Now, is it more likely that there'll be more bounce light at the bottom here of the wall or towards the top? Well, to find that out, you can ask yourself this one question. Is it more likely that it'll bounce here on this wall right here? Or is it more likely that the same light particle here will bounce at the same location and up here, right next to the sphere and onto the moon, which is located back there? Which is possible, you know? It's a possibility. It's not completely impossible. And I think most people would agree that it's probably more likely that we'll get bounces when it's closer to the initial impact here, and much less likely that we'll get bounces on the moon. There's no difference between the two objects other than one is really, really far and the other one is closer. And so what can we deduct from that? It means that everything that is closer to the original light impact from the main light source, in this case, you know, the entire ground here, everything closer to that will be a little bit brighter because we'll get a little bit more bounces. It's more likely that the light will bounce there. And so now we can grab the color of the floor, reduce the intensity to about 1/3 of it, and apply it on all the walls and the side of the boxes. And then the ball here will also get some bounce light, you know, just like this wall. We can take the same kind of color at the base because, you know, those light particles will come down from the sky, from the sun, bounce here on the ground and back onto the underside portion of the sphere. And now, like we've established, all the surfaces that receive direct sunlight will act as the source for the bounce light. And so everything that is closer to those surfaces will get a little bit more light. So what we can do is select here the lower portion of the wall and brighten that up just a little bit. Now, if we point our attention to the box right here, whatever is closer to the light source, in this case, the base of the cube, will get more light. And then there's one last thing in here that we haven't really lit, and that will be the underside and the side here of that little roof. So taking into consideration the same principle where the light bounces off the ground or bounces off this little sphere here, it will probably at some point bounce back up here and illuminate the bottom of this roof. Probably not as much as the wall, but still a little bit. The same goes for this side here of the wall. Probably will get some light. And I forgot to color the other side of this cube here, so we're gonna do just that. So with bounce light, it looks a lot better, but there's still something that's a little bit wrong in here. And I don't know if you can spot it, but it would be this box here. This box, it emits a different color of bounce light. And we don't have any colors here on the wall, and so we should definitely have that. So I'm going to select the same color here, and the bounce light from this area, from the top here portion of the box, not the side here too much because there's no direct sunlight hitting the side of this box here. So if anything, the side of the box will only get the bounce light from the ground. That's it. So when the light goes down here, the light from the sun goes down here, hits the box, and then bounces back onto the wall. The wall itself will get a little bit of that bounce light too. So we should definitely add that in there somewhere. So maybe, so the box is right about here onto the wall. So probably right next to the box here, right? So probably in this area, kind of close to this area. Of course, not down here because there's no way the light can do this and kind of curve down. It can only bounce up or bounce parallel to this box. The bounce light will probably be kind of like in this area here. Very subtle though, because that box doesn't have that big of a surface area for the light to bounce on. And the box is relatively far from the wall. It would be a lot bluer if the box was closer. And you might be able to see it on the other side as well here, but probably so subtle that we wouldn't see much. Okay, so we've taken into consideration now one light bounce, right? So the light from the sun goes down here on our scene, touches something and then bounces back onto something else. That's one bounce, but it doesn't stop there. The light is not satisfied when it gets there. It's not like, oh, I've bounced once, I better stop. It will keep bouncing as much as it possibly can until it gets completely absorbed. And so this is where it gets a little bit confusing. But the main thing to know is that every time it bounces, it loses intensity. Some of that light gets absorbed, right? So maybe we had a lot of light in the initial bounce right here. And then when it bounces off the ground, we only get a little bit of that left. And then once it hits the wall and bounces off somewhere else again, below here, maybe it goes down into the shadow, well, now there's only a little bit of light bouncing again. And if it were to bounce again, maybe a little bit, and then even less, and then less and less and less and less until you can't even notice it. So I am pretty aware that this gets really complicated really quickly. So what I recommend, is usually to just consider that there's just one light bounce. It just makes things easier. Only reason why I'm pointing this out is because, as you can see here, this bounce resulted in some of the light particles hitting that shadowed area here. So then as a result, that shadow shouldn't be as black as it is right now. It should get a little bit of light. Not much, of course, but a little bit. And so what we can do with that is just maybe tone it down a bit like that, so that it's not as intense. And we know that it's still pretty dark. We know where the shadow is coming from. We know that it's these things here casting the shadow, because the shadow is still the darkest of them all. It's what blocks the main light source. But as a result of all the light bouncing around the scene here, we still get a little bit of light on that shadow, so it's not as pitch black. And then finally, we can move on to the last source of light, which is going to be the sky here. And so the sky, again, is going to be much weaker and will be kind of everywhere. And so what I'm going to do is, on a new layer, using the same blue here that I have for the sky, I'm going to cover the entire layer in the same blue and set it to a lighter color, because that reflects what is happening in real life a little bit better. So in reality, the blue will add to the highlights here on the ground, on the top of the sphere. Again, we'll add a little bit of brightness to the areas where the sun is hitting as well. But the light from the sky is so subtle that it won't really make any difference. And so when you have lighter color will only add light in the dark areas. And so as you can see here, the ground remains the same color. It's really more the shadow areas that are going to get a little bit more light. But the main difference here between the two will be the shadows now. The shadows will have kind of like this tint now because of the sky, this bluish tint. So even though that light is coming from everywhere, there still are going to be some areas where this light sky won't be able to reach. Maybe below this little roof here, and probably the base of the sphere in general. Because again, this light source is coming from the top. So we have the bounce light that is coming from this entire section, from the entire ground section. All the areas are being lit by the sun. We have the sunlight that is coming from the sun itself, and we have the skylight that is coming from the sky. And this is the logic behind it. And there's one more thing that I really like to add, and that is going to be called ambient occlusion. Ambient occlusion is a term that is very well known in game development. And really what it means is just that in corners or in cracks and crevices, it's harder for the light to escape. If you look at somebody's ear, inside their ear or in their nostrils, it's not going to be illuminated. Usually it'll just appear black to you, right? You can't really see inside there because the light that goes in there can't escape. It just enters and never comes out. And it's not a magic trick that your nose is pulling on you or your ears are pulling on you. It's just that the light, every time it bounces, it loses intensity, like we said. And so whenever it bounces a lot, it has more chances to lose intensity. And where does it bounce a lot? Let's say we have something like this. Now let's take a light ray here. So a very strong light ray coming all the way down. So this is a bunch of light particles and it bounces off this ground here. It can bounce in any direction from there, right? It can bounce in 180 degrees. So it can bounce here, it can bounce up here, any direction it wants. And then when it bounces, it's going to lose a little bit of its intensity, so it'll be a little bit weaker. Maybe it bounces up there, or maybe it bounces up here. And when these bounces happen, there's not much in the way to block them. So it's a lot more likely that you'll see the light from the particles that hit this flat surface here than the one in here, because what happens when those light particles reach down here, well, now they can still bounce, but it's way more likely that when they bounce, they're going to hit a wall. right? And again, what happens when you hit a wall? You lose some intensity. So let's say we'll have the same intensity here, right? So we'll keep the same width. So it bounces here, back up onto this wall. Now it bounces again. It loses even more intensity. Maybe it's going to bounce out, potentially, but there's so much wall next to it that's probably going to hit another wall. And then when it hits that other wall, it will be absorbed some more. And so there's only maybe a little bit that might be able to come out, if it's able to come out at all. Maybe it'll just bounce again on another wall and just be completely absorbed and not have any particles left to reach your eyes. And so in most crevices, holes, cracks, or whenever two walls come together to form a corner, it's more likely that the light will bounce around, losing more and more energy, and by the time it reaches your eye, it'll be very, very weak, and thus appear darker. If we remove this and look at our scene again, what are the areas that match those characteristics? Probably not here, right? It's just a flat surface. It can bounce in any direction. But what happens if we look at the corner of the wall here? And so usually, although it'll be very subtle and it depends on the scenario, but usually speaking, AO represents the loss of light in those corners where the light gets trapped and can never escape. And this will simply be represented by a lack of light coming back from here. And so what we can do with a soft brush and a dark color, softly go over it to add a little bit of darkness to the corner in these corners on each side and in any other corner in the scene here. Whenever two surfaces or more come together, you'll get ambient occlusion. Don't do it too much. So right now, this is a little bit overdone. It looks kind of weird. So you want to get rid of some of it. And the closer we are to that line, the closer we are to the intersection, the more the effect will be pronounced, right? So it won't be really pronounced up here because that's pretty far from the corner. But as you get closer and closer to the corner, it'll get darker and darker. And we'll have the same thing here at the base of the sphere. Same thing with this cube here. A little bit of light lost all around. And we'll have the same for that little roof here in every corner. So as you can see here, it's just a little bit, but it just grounds everything. When you take it away, now it looks like this cube is just kind of floating there. So if you play video games at all, this is probably something that you've seen before and you might have been aware of it already. But ambient occlusion is really just that. Whenever you have two or more surfaces that come together, that intersection between those two surfaces will make it harder for the light to escape and therefore will appear to be slightly darker. And the deeper the crevice or the deeper the hole, the less likely it is for that light to come out, and so it'll appear darker. And I don't think I need to mention this, but just in case, ambient occlusion only happens when there is a bounce possible, when it can hit a wall, right? So it'll happen here at the base of the cube, but it won't happen towards the top there. So the main idea here is to just be conscious of the light bounces. And it's really what complicates things here. Because if we were only using one light source, that's pretty simple. It's pretty straightforward. But what makes a drawing or a painting or a character really look great will be the result of adding together all those different light sources. And once we're done with the process, well, we can always color balance things out to give, the proper mood to the scene. So if you want something to be a little bit warmer, if you're feeling that this is a little too cool, well, we can do an overall tweak and maybe add a little bit of warmth in here. So something like that, perhaps. And since this is an overall change, everything should still work. As you can see here underneath the little roof, it's a little bit more yellow than the shadow here because the shadow is being impacted by the nice fuzzy light from the sky, giving this its subtle blue tint. And well, this is going to bring this class to an end. So we've had a look at a lot of different things in here. We took a look at color psychology, color temperature, including perceived color, how color temperature can affect our spatial perception of different objects in our scene, and how warm and cool colors alike can take up different properties depending on which colors they're next to. Then we took a look at gray and its close relationship to shadows and how we should usually aim to have tinted shadows, but not only that, tinted shadows using a complementary color to the main light source or the main color of the lit area for a richer result. And we've just tackled 3-point perspective. So right now at this point, you should be able to light up pretty much any scene. So as long as you keep in mind the main types of light source that we've covered, so direct light, so the sunlight, your main light, your key light, bounce light, and ambient light, or the skylight in this case, you should be able to apply this towards any interior environments or really any kinds of scene that you want. And so I hope you learned a thing or two, and I will see you next time.